Hello and welcome to the first of the bonus lessons that we have lined up for our drum game project. In this video, we are going to start the process of putting together a vertical style renderer that will add into our modular rendering system that we've put together for the drum game. Currently, we have notes that are scrolling across your screen from right to left. It's a totally horizontal setup. What we're going to do is show you a separate rendering module that will plug right in that allows you to switch over to a vertical style, which is going to be kind of inspired by the type of gameplay you see in games such as Rock Band and Guitar Hero, where notes are going from the top down. Now, they're not going to be going from far away toward you. Again, this is a 2D game. We don't have any concept or handling of 3D space. If you wanted to add that later, of course you could. Now, the way we're going to be doing it, these notes are going to be going from the top down. We'll talk more about what that means in terms of code here in just a moment, but there's no reason why, if you wanted to, you could change this as we're coding and just flip really some positive and negative values and have those notes scroll from the bottom of the screen to the top, so it was actually fashioned maybe a little more after such games as DDR.
Right, after the end of this section, you should be very comfortable with swapping all of the coordinates around used in the rendering module. And that will let you come up with any kind of effect that you'd like.
Yeah, so however you want to handle that. But let's talk a little bit about what we've got going on right now with the horizontal renderer and how this is going to change as we switch over to a vertical renderer. So right now, we have a system that's very similar to what you see here. Basically, I've got a simplified screen and a simplified staff. As we play the game, we see notes that kind of start over here on the right-hand side of the screen, and they make their way this way. Now, that means the whole game is really taking place along the x-axis. Now, as we all know, the upper left-hand corner of the screen is 0, and the lower right is going to be your max resolution. For this example, just because I'm writing stuff down, let's pick something very easy to remember, like 640 by 480. So as we move in the x-axis, our notes, just in terms of their motion during actual gameplay, are going to begin at a value of 640, and that number is going to decrement, so that means that this way is kind of positive and this way is negative. So as you update the game, as the ticks go by, as you're sitting there getting ready for the drum game, this value is starting at your max resolution and it's ticking its way down. As you place notes, when you're in edit mode and you're got your little cursor and you're slowly panning up to drop more and more notes, that means you're dropping notes in a positive direction.
Also, if you're looking at the rendering system from a static standpoint, like you're just saying, if you're in render mode, but you're actually
in
edit mode. Yeah, exactly. But if you're in edit mode and you're just looking at the way notes are drawing, even if the song is not moving at all, the rendering system still has to start at note 0 and progress note through note.
Right.
And as subsequent notes are drawn, they're drawn to the right or in the positive X of the previous note.
Right.
So if you're looking at the direction of note drawing, that goes positive in X. But if you're looking at the direction of the motion when you're playing the game with the way the notes are panning, that's going in the negative X.
So we'll say note drawing is positive, but motion is negative, and all of this is going to be along the x-axis. So I mean, really, that's the key of our horizontal rendering system right there. Now, if we switch down here, I've got a mock-up of a vertical system. This is going to be very similar to what we'll be creating in a second. In this case, the primary axis of gameplay, of game editing, everything, is really going to focus now instead on the y-axis. Such that as we add notes, as notes are being drawn, like what we were saying earlier, that's going to be handled in a negative direction, because as you go up the screen, that's actually a negative value. However, during playback, the actual motion of those notes is going to be downward, which is a positive value. So not only are we swapping from the x-axis to the y-axis, we're also reversing our motion versus the note drawing.
Exactly. So we'll have to counter that in two key areas of the code, and that is, one is going to be the plotting or the drawing of actual notes here. Well, if you're starting from, say, the middle of the screen, you're going to be drawing up the screen in order to draw subsequent notes. So that means note drawing is actually going to take place in the negative y-axis. And if you're looking at the motion, notes panning across the screen, they're going to be moving down the screen, which is the positive y-axis.
That's right. And of course, all of this, just to complete our notes, is taking place in Y. So really, that's the key difference there. And once we get that all set up, the render is pretty much going to take care of itself. Now, the other kind of core aspect that we got to work in here is that both of these two rendering systems are part of the modular renderer that we've already put together.
That's right. We'll just make a second renderer class. Like, for example, we've already got a renderer base class that handles management and gives the basic interface presented. We've already got that extended into renderer horizontal. Now we're simply going to make something to go along with renderer horizontal. So we'll make a class called renderer vertical.
And by setting it up in this way, it's very easy for us to basically build an in-game switching system so that as you play, on the fly, you can jump from the horizontal render to the vertical render and choose whichever one you enjoy the most.
So one other thing I will point out is that a lot of the code is going to be very similar back and forth since, I mean, there are obvious similarities in the fact that they're both 2D coordinate systems. They're both plotting notes. One axis is used for motion, the other axis is used for tracks. So we're actually going to reuse a lot of the code that is currently in the horizontal renderer.
Well, it only makes sense. The two different rendering systems are doing the exact same job. They're just doing it in different directions, and really that's about it.
But the main key thing we wanted to cover in this video was just to get the coordinates, the way the coordinates are going to be transformed, getting all that locked in.
Okay.
One other thing I do want to point out is that the vertical renderer is not going to be taken as far as a horizontal one was. What I mean by that is we're not going to address background drawing or edit mode drawing, because there were a lot of special considerations in edit mode, things like the cursor and the grid and so on and so forth. Now, if you follow the path that we take in making the vertical render up to that point, it would be very logical to finish that off to the full editing system, but we didn't want to make the video unnecessarily long just to show transforms over and over again.
Gotcha. So, I mean, really, it'd just be reapplying a lot of the things you'd already covered when we were setting up the horizontal version of it, just applied in the vertical direction.
Exactly. This is just to keep everything clean and to the point.
Okay.
So, with that now, I do want to spend a moment and jump into Visual Studio just so that we can get some of the setup out of the way. What I mean by setup is we need to get a alternate graphic set up for our note, because currently our notes are kind of that vertical looking bar type note. Here in the vertical renderer, though, we're going to have more space across the screen. The screen is generally going to be wider than it is tall, especially on things like high-def televisions. So what we're going to do is we have an alternate version of the note graphic prepared that is wider than it is tall, and we're going to put that into place for our vertical render mode.
Okay.
Then we need to set up we actually need to set up a special input key, because up till now we don't have the input system doesn't care about renderers. There is no key, or no named input that is assigned to the function of changing our render mode. So we're going to set one of those up, and we're also going to get the base class to the vertical renderer set up and ready to go. So to take care of some of these foundational elements, let's jump into Visual Studio. And the very first thing we'll address is getting the new note graphic imported. I'm going to jump up under the Content subproject and expand Style, where we are currently storing all of our graphics. And I want to jump out to the file system, where I have prepared this brand new PNG, note_vertical. We need to get that imported, so I'm simply going to drag it in place, and that will set it up here inside of the Solution Explorer. Just like all the other graphics, it should already be set up to compile and be ready to go. Now, in order to gain access to this texture asset, we do need a field stored inside of the game so that we can see it. Now, we're storing all of our texture references currently here inside of our style.xml file, or excuse me, our style class based on that file. So the actual class is up here under game, and if we load that up and we scroll down to the style class itself, you see here we have a field for our note texture. We need a copy of this field to be used for the vertical version of the texture. So what I'll do is I'll duplicate this field, and I'll change the name to note vertical texture. Now we do need to make sure that the note asset gets loaded into it. So I'm going to jump down here to initialize here inside of the style class, copy and duplicate the note texture field. We'll change this again to note vertical texture. Then when we're loading in the asset, we'll load in note_vertical. Alright, that should take care of getting our texture asset set up. Now we need to address the input. We need to have a dedicated input that can be used for changing render modes. So in order to create this new input item, we'll go up here to core, load up input.cs. The very first thing inside of our input code file here is the named inputs enumeration. That contains all the different inputs that the game will recognize. we want to add to this enumeration a new value called render mode. Now, we also need to bind a key in our input binding system, rather in our config file. So, in order to make sure that this input is recognized, or rather bound to a specific key, we'll jump up here to our content project and load up config.xml. And for simplicity's sake, we'll simply take a keyboard key and we will bind it to render mode. So what we'll do is, in order to save time, I'll grab the line that is currently used to bind the space key to the reset input and copy and paste to duplicate that line. Now I can change the device input here, which the device is a keyboard, so the actual input is a key. We'll change this to the tab key, and we'll change the game input to render mode. Now you can see that this has kind of pushed our columns out of alignment a little bit, so I'll spend just a moment and pull these back in place, just so that everything's looking nice. Because up till now, every time we've added inputs, we are keeping all the columns in line just to make it a little bit easier to read.
Sure.
The nice thing that this process does show is the fact that it's relatively easy to add new inputs into the system, because we've got the main enumeration that defines the available ones. We have the config file that describes the bound inputs. But as far as inputs concerned, that's about it for the system. Since we've already got the system able to parse the text names into actual enum values, that's it for the introduction of a new internal input.
Right, and there's no reason why on the actual Xbox 360 controller you couldn't find maybe some button you weren't already using.
Exactly, and bind it up the same way now, because any valid device input could be bound to render mode.
Like maybe one of the shoulder bumper buttons or something.
Right. Now, alright, with this new key bound and usable inside of the game, we need to put it into use inside two of the classes. We're going to allow the game screen and the free play screen to switch modes at will. So in order to make them aware of this new incoming input, we need to go up here under Game and bring up Screen Game and Screen Free Play. So first here inside of Screen Game, we're going to scroll down to our input pressed method. Then at the very end, the last input that we're handling is the pause button. This is convenient because it's a simple else if clause that's looking at a single input. I'll copy the entire else if clause, paste it to duplicate it, and that way we can more quickly gain access to the input itself, named inputs.render mode. And in the event that we see a render mode press, what we want to do is tell the main renderer class, the static management code inside the renderer class, to change to the next renderer. We do that by looking at renderer, and then we simply call upon the method change renderer. Now, we want to be able to do the same thing inside of the free play mode, so we're going to copy this new else if clause handling render mode, jump over to screen free play, then we'll scroll down to the input section for our free play screen, jump in here just below the pause button handling, and paste the additional code for looking at render mode as the input, and then changing the renderer on the actual renderer class. And the reason we're handling it this way, where each screen is responsible for changing the render, is to give ourselves a little bit more control, as we do have a screen that we don't want to be able to change the render mode, and that is, of course, the editing screen. As we already described how the vertical render is purely for gameplay purposes, we don't want to allow the user to swap over to that screen from edit mode.
Okay.
So if we leave the render mode changing to be the responsibility of a specific screen, that means screen by screen we can decide whether or not the render mode can be changed. Alright, one last thing we need to take care of in order to wrap up this video, and that is we want to begin the render vertical class itself. We want the actual renderer class in place and usable, and we want it to be selectable. We're not going to add any of the actual drawing code in it yet. We just want to get it in place and show how it ends up getting registered into the renderer system. So, in order to create the renderer, we're going to stay right here inside of the game folder, and we will make, or rather add, a new class. This class is going to be called Render Vertical. And then we'll drop that in place. Give it a second to load up here inside of the editor. We will take out the sub namespace of .game. We need to add in some using statements. So I'll drop in a using for Microsoft.xna.framework, and then a second using statement for framework.graphics. Now the renderer itself, of course, needs to inherit from renderer. So we'll say that class render vertical extends renderer. And if we were to try to build at the moment, you'll notice that once the build finishes, we get an error, and that's because we defined the draw method as part of renderer as an abstract method, meaning that if we extend renderer, we have to provide an implementation for it. So, just to make sure that our code will build, I'll drop in the override for draw, and then take out the default exception that gets thrown in place, just so that we can indeed build. Now, for the time being, we will leave this class empty, other than the obvious draw override. The reason that we're dropping the class in at this point is so that we can show how it gets registered into renderer. If we jump over to our game class, game1, and we scroll down to the load content method, and then near the bottom of load content we have our renderers section. The idea that in order to, as I was saying before, register a renderer, all we're doing is instantiating it and adding it to the renderers list that is part of the renderer class. So we're going to do the exact same thing in order to register the vertical renderer. So I'll copy the current line being used to create renderer horizontal. I'll change it to renderer vertical, and that should take care of it. That will register it into that list, and it should be ready to go. Now, I do want to jump in and test briefly, since at this point we have all of the groundwork laid. We have inputs that should allow us to gain access to the various renderers, and we have a renderer class put in place. So let's build and run the game, and jump into single player, jump into a song, and now if I were to hit the tab key, all of our notes disappear. And then give it a few more seconds, we hit the end of the game. Let's jump over to free play mode so we have something that will play for longer. You'll notice that our new renderer is still in place as we cannot see anything, but as we hit the tab key, we can toggle back and forth between the two renderers now.
Gotcha.
So we've already got the management code set up and working inside of the renderer class, and now we do have multiple renderers in place, so it is able to change between them. You'll also see that our game screen and our free play screen are able to switch between renders. So with that, that's what we needed to cover in this video. Again, just going over the basics of how the new render mode should work and setting up the class and everything around the class to make sure that it all functions properly. So that's going to take care of this video.